Alright. Good afternoon, everyone. I hope you're having a good day so far. So today in this lesson, we're going to do 502, errors in measurement and percentage error. So the merits of, or like rationale of this thing is that first of all, we're only human, right? So sometimes in measuring things, we make mistakes, either by accident or whatnot. And also, even on your ruler, there might also be inaccuracies going on. So there's not going to be two rulers that are exactly the same. That's just life, I guess. So we say the limit of reading or precision is the smallest unit on the measuring instrument. What's that? So for example, for a ruler, so this thing here, we see that 20 centimeters and 30 centimeters, and there are 9 different intervals, and they cut 20 to 30 into 1 millimeter each. So 1 millimeter is going to be the limit of reading. That's the most accurate I can read too. So I can get, say, 5.3, 5.2, 1 decimal place because of the 1 millimeter, right? I can't say if I just use a daily use ruler and say, okay, I measured it to be 12.345. You know I'm bluffing. Like it's not realistic to have done that, right? Because it's not even on the ruler. How am I supposed to know? So now absolute error, which is always going to be a question in HSC multiple choice, is equal to plus or minus half times the smallest unit. So what does the smallest unit mean? So it's the value that you can measure to. So your limit of reading. And the percentage error is absolute error on the top and measurement on the bottom, and you times that by 100. So these are the two formulas that you need to memorize. So examples. So 3.2 grams. How many decimal places are there? There's 1 decimal place, right? Because there's 1 decimal place, I know I can actually measure to the nearest 0.1 gram. So this is going to be the smallest unit in the formula. So the absolute error is plus or minus half times 0.1. And in your calculator, you don't put in the plus minus sign. You just write it in the front, and then you put in a half times 1.5 and see, 0.1, and see how much that is equal to. And that's going to be the absolute error. So it's plus or minus 0.05 gram. So the unit is the same as what's in the question. What it means is, if the reading is 3.5 gram, then that means there's a possibility that my answer is 0.05 grams off. That's what it means. So it's not completely accurate. Alright, next one. 4 centimeters. What's the nearest? How many decimal places are there? There's no decimal place, right? But it's to the nearest what? It's to the nearest 1 centimeter, right? Because it's a whole number, to the nearest 1 centimeter. So this is actually the smallest unit. So what you do is plus or minus a half, that's the same in every single question, times the smallest unit. In this case, it's 1. So you're plussing or minusing 0.5 centimeters from the original answer. So it gives you a ballpark of what the actual length is. Alright, 67.72 mils. That's to the nearest 2 decimal places, right? To the nearest 0.01, because there are 2 decimal places. 0.01 mil. So 0.01 is going to be the smallest unit. So plus or minus a half times 0.01. That will give you plus or minus 0.005 mils. Okay. Next question. The capacity of a bottle is measured as 1.25 liters and is corrected to the nearest 10 millimeters. What is the absolute error? Okay, I think here there's one thing you need to be careful about. 1.25 liters, and it tells you it's to the nearest 10 millimeters, right? Everything we've done before, it's grams and to the nearest 0.1 gram, centimeters to the nearest 1 centimeter. This many mils to the nearest mil. So all these units have to match. How do you match them now? You always match whatever to the actual measurement. So what's 10 millimeters equal to in liters? I'll just write mils. 10 mils is equal to divided by 1,000, right? Because you're going from small to big. So divided by 1,000, this is 0.01 liters. So that means it's actually to the nearest 0.01, which is the number you're using in the formula. So you do plus or minus 1/2 times 0.01. So that's plus or minus 0.005 liters. This is your absolute error. But then the question also asks you for the percentage error, right? So I'm just going to label everything because there are two things that I need in this question. So absolute error is equal to that. And then we also know percentage error is equal to plus or minus absolute error on the top, that's just the formula, over the actual measurement, times it by 100 because it's a percentage. So now you have plus or minus 0.005. So in your formula, you just use the numerical value. You don't put in the plus minus because there's also already the plus minus in the front, right? Over 1.25 times this by 100. Now, once again, when you put into the formula, into the calculator, you don't use the plus minus. You just put it in the front and put everything else into the formula, into the calculator and see how much it is. And that actually gives you 0.4%. So that means there's a 0.4% error in my calculation, which is pretty. Alright, so the answer for this question should be the absolute error is 5 mils. I know that some of you are thinking, hey, this is to the nearest 1 mil. Why am I not using 1 as my absolute error? That's because if you actually look at a measuring cup, for example, this one, a measuring cup doesn't go 1, 2, 3, 4, 5, 6, 7, 8 all the way up, right? It probably just goes up by 10 or 50 or 100. It depends on the cup. But then for this one, it's 760, so that means it's definitely going to have 750, 760, 770, so on and so forth. So it's actually going up by 10 mils. So this is to the nearest 10 mils. Yeah, that's why I would get 5 mils as the absolute error, and then you use 5 to find the percentage error. Next concept is range of measurement. So I'll say, if I say a person is 170 centimeters, I mean he's probably between 169.5 to 107.5. I'm just getting the average. So because there's that error, right? So error is plus or minus. So if you minus, that's the lower limit. So you do the actual measurement minus your lower limit. If there's a larger value, so the larger measurement, the upper limit, you add the absolute value to it. So the first step, you've got to find the absolute error, right? So for the first question, Bill weighs this much. Calculate a range of possible values. So first of all, absolute error is equal to plus or minus 1/2 times the smallest limit. what's the smallest limit? So you have one decimal place here, which means you're rounding up to the nearest 0.1. So 0.1 is the number here, plus or minus 0.05 kilograms. Now it says to find the lower limit, you do the actual measurement, so 77.6 minus absolute error, 0.05. So this will give you 7. It's going to be 77.55 kilograms. And the upper limit is 77.6 plus 0.05. So 77.65 is the upper limit. So if I want to write it as a range, it goes from the small to big, right? So 77.55 kilograms to 77.65 kilograms. This is the range. So whenever a question asks you for the range, you need to find the smaller bound and the bigger bound, right? Alright, next question. I want you to first take some time to do it first. So for this one, even though it is to the nearest 1, but in real life, how does it work? When you're counting people in such a large venue, it's got 000 at the end. So actually, we're rounding it up to the nearest 1,000 people. Right? That's because we're looking at real life. If it's a measurement, then it will be to the nearest 1 centimeter, for example. But if we're looking at people, then it's to nearest 1,000. So you'll have absolute error is equal to plus or minus half times 1,000. So that's plus or minus 500 people. So the lower limit is equal to, so your actual measurement minus the error. And then the upper limit is equal to 87k plus 500. So that's this much. So if, say, a news report says this venue contains 87,000 people, then in reality it's going to be between 86,500 and 87,500. This is how many people this venue can actually contain. So once again, the reason why it's to nearest 1,000 people here is that there's a lot of people, right? So I'm not going to count. It's like just using common sense. No place is going to tell you we can have 679 people. It's not that specific. It will just tell you 700. Okay, question 6. I'm going to do one of them with you and then let you do the rest yourselves. So for the first one, precision for it, I'm just going to use P, M, and where the absolute error. So absolute error is going to be A and range is R. I'm just going to use the short forms or else there's no space. So the precision is 0.1 centimeter, right? So the actual measurement is 5.8 centimeters, and the absolute error, so it's going to be plus or minus half times 0.1, which is plus or minus 0.05 centimeters. And the range is going to be from 5.8, you either take away 0.05, so that's 5.75, to the upper limit, 5.85 centimeter. You just add 0.5 to it, right? And I'll let you do the second one yourselves, but I'm going to show you the answer in a second. And I also just wanted to quickly talk about question C. C, D, and E are very similar. So for these ones, what's the position? So you have 60, 70, 80. Now actually you only showed 60 to 80, right? But does it tell you anything else? Not really. The only thing you know is because there's a line in between. This line means 10, 70, right? So it goes up by 70, but it doesn't tell you that. But other than that, you don't really know much. So for this question, it's to the nearest 10 because it goes up by 10, right? 0, 10, 20, 30, 40. So it's to the nearest 10 kilometers per hour. Or you can just think, from 60 to 80, it went up by 20 all of a sudden, right? So I can only read the middle one. The middle one is 20 divided by 2, 10. So the measurement here, it's actually 60 kilometers exactly. And the absolute error is plus or minus half times 10. So that's plus or minus 5 from 60 to get a range. So 60 minus 5 is 55. 60 plus 5 is 65. So this is going to be the range. Now I want you to take maybe 3 or 4 minutes. There's actually one more question F. 3 or 4 minutes to quickly do the rest of the questions yourselves, and then we'll compare the answers together. Did 2, and I figured E and F are slightly harder, so we should probably do them together. For question B, it divides 1 centimeter into 2 parts, right? So 1 divided by 2, that's 0.5 centimeters. So the position is 0.5. And the actual measurement, this is where it gets a bit tricky because you see that this line clearly exceeds 11.5, but my measurement is actually 11.5. That's because there's no way for me to know exactly how much that is. So you only read whatever that's on the ruler. So on the ruler, this is closer to 11.5 than 12. So I'm just going to keep 11.5. So the absolute error, half times 0.5, plus or minus 0.25, minus and add to the measurement. This is how I got this. Question D. Say, for example, from 100 to 120, there are 1, 2, 3, 4 parts, right? So I got 5 from doing 20 divided by 5. 20 divided by 4, because there are 4 parts. So it's 5 kilometers per hour for the position, and everything else should be simple enough. This is a thing showing revolutions per minute. So how fast the engine is working. And it says times 100. So every number actually stands for just the first part of that 1,000 number. So if it's 10, that means it's 10 times 100, 1,000, 2,000, 3,000, 4,000 revolutions per minute. So the position for this question, from 0 to 10, there are 10 parts, right? So it's going, but this is actually 0 to 1,000. So for 1,000, you divide it into 10 parts. That's 100 revolutions per minute. That's the position. And the actual reading, it's 2. But don't forget, it's 200. Because of the unit, right? And the absolute error, plus or minus half times 100. So that's plus or minus 50. So the range is going to be 200 minus 50, 150, to 200 plus 50, 250. All right, next question. So volume now. To find a position, we see from 2 to 3, that's 1. It's divided into 2 equal parts. So 1 over 2. That's 0.5 cups. So yeah, because it says cups on the top, so it's from 2 cups to 3 cups. That's a 1 cup jump. So 1 cup divided into 2 equal parts, 0.5. And the measurement is 7 exactly. So absolute error is plus or minus half times 0.5, and that will give you plus or minus 0.25. So the range is going to be 7 minus 0.25, which is 6.75, to 6 plus 0.25, 7.25 cups. Yep, so that's the end of absolute errors. I know it's probably a little bit confusing because of all the units, and every question is slightly different. But try to go through all these examples again before you attempt the homework. So homework is just 502. Let me see how many questions there are. So 13 questions. Could you please make sure that you copy down all the notes and also finish your homework and submit by 11 a.m. tomorrow. Thank you.